The Gowanus Canal in Brooklyn, New York is a toxic brew of all kinds of pollutants. Heavy metals, pesticides, even sewage flows through this canal that has been in industrial use for more than 150 years. But researchers at the Massachusetts Institute of Technology are working on ways to clean up that water using simple electrical current.
In red, we have the positive electrode. In green here, we have the negative electrode. And then inside the cell, we have the pollutant and then our electrodes are being immersed so they can have the water in contact with the electrodes to be able to absorb the pollutant. And then we have the little tiny stir bar here stirring.
It is not quite as simple as it sounds. The electrodes are coated with special polymers that target specific pollutants, and that is part of what makes this process so unique.
While there have been many types of separation processes based on electrical driving forces and things like that, they really don't have the selectivity that we want to go for in a lot of the applications of interest. They also don't have able to address capturing micropollutants, things that are very, very low concentration.
This time-lapse video shows how the process works. Little by little, the electrodes pick specific pollutants out of the water.
So our idea here was if we can put polymers on the electrodes, that they can be charged up and they can then capture systems selectively. For instance, we can take one molecule of an organic contaminant out of hundreds of molecules of other surrounding salts. If we can do this selectively, we've got a big winner on our hands. And that's really what we've been developing.
Not only is the water clean, but the process itself is greener than current cleanup methods that use heat, high pressure, or even chemicals.
And what we'd like to do is come up with a system that be much cleaner. And what is more clean than using electricity, at least at that level. And what we like to do is have a technology where we can flip the switch, the light goes on, and we can do the separation. We turn the switch off, the light goes off, and we are able to regenerate our systems.
Researchers say the process can be scaled up quickly and could soon be working outside the lab to turn this into this. Steve Reddish, VOA News.